Last time, we explored how between any two numbers like 1 and 2, we can find a bunch of others like 1.5 or 1.25. But what if there are numbers that don't play by those rules? Numbers that can't be written as a simple fraction, and whose decimals just go on and on and on without ever repeating a pattern? Sounds wild, right? Welcome to the world of irrational numbers, where math gets mysterious and infinity never loops back. Alright, so what exactly is an irrational number? Let's break it down. A number is called irrational if you can't write it as p divided by q, where both p and q are whole numbers and q isn't zero. Instead of nice, clean decimals or fractions, irrational numbers have decimal parts that go on forever. But here's the twist, they never repeat a pattern. So if a number goes on endlessly and never settles into a loop, boom, it's irrational. Let's meet some of the most famous members of the irrational number club. First up, square root of 2. It's roughly 1.414, but the decimal never ends and never repeats. Next, there's the legendary pi, the circle superstar. Its value starts as 3.14159 and just keeps going. Then we have square root 3, square root 5 and others that don't simplify into whole numbers. And even strange decimals like 0.101111 that look random and never settle into a pattern. These numbers can't be turned into neat fractions. That's what makes them irrational and kind of awesome. Irrational numbers aren't just some strange math idea, they show up in real life all the time. For example, ever measured the diagonal of a square? That diagonal isn't a whole number, it's square root of 2, and yes, it's irrational. And what about circles? Every time you work with the circumference or area, you use pi, an irrational number that helps define roundness itself. Even architects and engineers use irrational numbers to design bridges, buildings, and machines. So yeah, irrational numbers may not fit neatly into fractions, but they definitely fit into the real world. Alright, Number Explorer, it's quiz time. Let's see if you can tell whether a number is rational or irrational. First question, is the square root of 4 irrational? Well, square root 4 equals 2, and 2 can be written as 2 over 1. That's a fraction, so, nope. It's rational. Next one, what about square root 2? You already know, it goes on forever with no pattern. That means it's irrational. Last one, what about 0.6666 where the 6 repeats forever? A repeating decimal? Yep, it's actually a rational number. It can be written as 2 over 3. You're getting the hang of this, keep it up. Let's learn a quick trick to spot an irrational number, no calculator needed. Step 1, look at the decimal. If it ends like 3.5 or 0.25, it's rational. If it goes on forever but follows a repeating pattern, like 0.3333 or 7.12112, that's still rational. But if the decimal never ends and never repeats, then boom, you've got an irrational number. So next time you see a long, endless decimal, check if there's a loop. No loop, no fraction, it's definitely irrational. So where do irrational numbers fit in the big picture? Here's the answer. When you combine rational numbers and irrational numbers, you get the full team, called real numbers. That means every single point on the number line is a real number. It's either something neat, like 4 or 2 by 3, or something wild, like square root of 5 or pi. Together, they fill the number line completely, no gaps, no missing pieces. So next time you see a number, ask yourself, rational or irrational? Either way, it's real awesome work, Number Explorer. Now you know what makes a number irrational and how it fits into the big world of real numbers. You've cracked the code of decimals that never end and never repeat. But wait, ever wondered how decimals behave inside these number types? Stick around, because up next, we are diving into decimal expansions of real numbers. Let's keep exploring.